Hello, I'm Essay, your AI essayist. Please note that all content, audio and video in this presentation are AI generated. As AI can sometimes produce inaccuracies, I encourage you to verify any factual information presented. With that in mind, let's begin.
The intellectual landscape of mathematics in 1962 was one of profound transformation, particularly within the domains of algebra and geometry. The foundational project of Alexander Grothendieck and his collaborators, embodied in the Éléments de géométrie algébrique, was actively redefining the very language of the field, introducing a level of abstraction that was as powerful as it was demanding. Within this environment of revolutionary change, Michael Artin's Harvard lecture notes, titled simply Commutative Rings, emerged as a document of singular importance, circulated in mimeographed form. These notes presented a pathway into the new world of algebraic geometry, yet one paved with a distinctively constructive and algebraic sensibility. This essay will undertake a direct and systematic evaluation of the internal claims, arguments, and pedagogical structure of this seminal 1962 work. By proceeding through its logical sections, we will analyze the specific mechanisms Artin employs, assessing the coherence of his presentation and the profound implications of his chosen emphasis, which culminates in the foundational ideas of what would become the Artin approximation theorem. The work's enduring influence emanates from its architecture, a carefully sequenced argument demonstrating how concrete algebraic tools can be leveraged to resolve deep geometric questions. Section 1, establishing the geometric language of prime spectra. The initial sections of Artin's notes make a foundational claim that the collection of prime ideals of a commutative ring A, designated as the prime spectrum of A, furnishes a coherent and sufficient topological space for geometric reasoning. The argument begins by constructing this space. For a given commutative ring A, the set of all its prime ideals is taken as the underlying point set. The topology, now known as the Zariski topology, is defined by specifying its closed sets. These are the sets V of I, consisting of all prime ideals that contain a given ideal I of the ring A. Artin's presentation immediately grounds this abstract definition in classical experience by showing its relationship to the zero sets of polynomials in fine space, providing a conceptual anchor for those familiar with older viewpoints. The methodology is one of direct construction. He systematically elucidates the properties of this topological space, demonstrating its quasi-compactness through a standard argument involving the definition of the basic open sets. A key operative claim within this section is the utility of localization. Artin introduces the localization of a ring at a prime ideal P, denoted as sub P, as the primary algebraic tool for studying the local properties of the prime spectrum of around the point corresponding to P. The argument is that the ring of germs of functions at a point in this algebraic space is precisely this localized ring. This establishes a powerful dictionary, translating the geometric idea of examining a space near a point into the purely algebraic operation of localization. The evidence for this claim is the subsequent utility of the concept. Throughout the early chapters, localization is the mechanism that allows global questions about a ring to be resolved by examining its local rings, a sub P for every prime P. In evaluating this section, one recognizes its pedagogical efficiency. Artin presents the prime spectrum as a working tool. His claims about its structure are substantiated with direct proofs that the immediate introduction of localization provides the main engine for analysis, an engine he will use relentlessly in the subsequent development. Section 2, the centrality of modules and the introduction of flatness. Following the establishment of the geometric space, the notes advance a more sophisticated structural claim regarding the nature of relationships between these spaces. This section posits that the theory of modules over a commutative ring provides the essential language for understanding ring homomorphisms, and by extension, morphisms between their corresponding spectra. Specifically, the concept of flatness is introduced as a central organizing principle. Artin's argument here is that flatness is the precise algebraic condition that guarantees good geometric behavior of a map between affine schemes. He defines a module M over a ring R to be flat if the functor which sends an R module into the tensor product of M and N over R is an exact functor. The explanation of this definition moves swiftly to its geometric meaning. A homomorphism from a ring A to a ring B induces a morphism from the prime spectrum of B to the prime spectrum of A. The claim is that the flatness of B as an amodule ensures that properties of the fibers of this morphism, such as their dimension, behave continuously. The methodology is algebraic and demonstrative. Artin develops the theory of the tensor product with care, establishing its fundamental properties before leveraging it to define flatness. He then proves key criteria for flatness, including its local nature. A module is flat if and only if its localization at every prime ideal is a flat module over the corresponding localized ring. This allows the verification of flatness to become a tractable, local problem. The evaluation of this section's claims reveals their strategic importance. By centering a discussion on modules and introducing flatness so early, Artin equips the reader with a powerful, modern tool. This approach organizes a great deal of commutative algebra around a single, geometrically motivated concept. The claim that flatness is the key to well-behaved morphisms is substantiated by examples showing how its absence leads to pathological geometric phenomena, like dimensions of fibers jumping unexpectedly. The section thus forges a crucial link between abstract homological properties and tangible geometric intuition, a hallmark of Artin's style. Section 3, a constructive approach to dimension theory. The discussion then progresses to one of the most fundamental geometric invariants, dimension. The primary claim in this part of the work is that the dimension of a ring can be defined and calculated through a series of concrete algebraic constructions, connecting the topological notion of dimension to the homological properties of the ring. Artin presents the Krull dimension of a ring as the supremum of the lengths of all chains of prime ideals. This definition is immediately shown to be operational, albeit difficult to compute directly. The argument then pivots towards a more powerful, constructive characterization for Noetherian local rings. Here, the claim is that the dimension of a Noetherian local ring, with maximal ideal M, is equal to the minimal number of elements in M that can generate an imprimary ideal. These elements form a system of parameters. The methodology involves an elegant deployment of the theory of the Hilbert-Samuel polynomial for an imprimary ideal Q. Artin considers the length of the modules are divided by Q to the power of n as a function of n. He asserts that for large n, this function is a polynomial in n, and its degree is a constant independent of the choice of the imprimary ideal Q. This degree, he claims, is precisely the Krull dimension of the ring. This provides a computational handle on what was initially a purely topological definition. The argument culminates with the introduction of regular local rings. A regular local ring is defined as a Noetherian local ring whose maximal ideal can be generated by a number of elements equal to the ring's dimension. The section's core assertion is that these rings are the algebraic analogues of smooth, or non-singular, points on a geometric variety. The evidence for this is homological. A local ring is regular if and only if it has finite global dimension. In evaluating this section, its constructive nature is paramount. Artin systematically builds up the theory of dimension from its abstract definition to a set of powerful computational and theoretical tools. The claims are layered, with each new result providing a deeper or more practical understanding of dimension. The connection between the number of generators of the maximal ideal and the degree of the Hilbert-Samuel polynomial is a piece of classical theory, but Artin's presentation frames it as a direct path toward understanding regularity. The section succeeds by demystifying the concept of dimension, transforming it from a topological curiosity into a workable algebraic property. Section 4. The analytic lens of completion. Having developed the theories of localization and dimension, Artin introduces another transformative technique, completion. The central claim of this portion of the notes is that by passing from a local ring to its completion, one can often simplify problems dramatically, leveraging the well-understood structure of complete local rings to deduce properties of the original ring. The primary mechanism is the eidetic completion of a ring with respect to an ideal I, constructed as the inverse limit of the quotient rings are divided by I to the power of n. This process is analogous to the construction of the padic numbers from the integers. Artin's argument is that this completion process magnifies the local structure of the ring around the ideal I, washing away more global complexities. The methodology focuses on the structure of complete local rings. The centerpiece of this section is a clear and direct presentation of the Cohen structure theorems, which provide a stunningly explicit description of these objects. The aquacharacteristic case of the theorem claims that any complete Noetherian local ring containing a field is isomorphic to a quotient of a formal power series ring over that field. Specifically, if K is a coefficient field for A, then is isomorphic to the ring of formal power series in n variables with coefficients in K, modulo some ideal, where n is the embedding dimension of A. The power of this claim is immense. It asserts that the vast and seemingly chaotic universe of complete local rings can be understood in terms of these relatively concrete power series rings. The evidence for the utility of completion is presented through its applications. Artin demonstrates how Hensel's lemma, a powerful tool for lifting solutions of polynomial equations from the residue field to the complete ring, becomes a triviality in this context. The evaluation of this section highlights its role as a bridge between algebra and analysis. The claim that completion simplifies structure is profoundly substantiated by the Cohen structure theorems. Artin's particular achievement is to present this deep theory in a way that emphasizes its utility as a problem-solving strategy. He shows that by taking the analytic step of completion, one can resolve questions that are intractable in the purely algebraic setting of an arbitrary local ring. This sets the stage for the most innovative part of the notes, where this analytic perspective is brought to bear on the problem of finding actual algebraic solutions. Section 5, the bridge to solutions via Henselian rings and approximation, the final major thrust of the 1962 notes, contains its most original and forward-looking contribution. This section advances the radical claim that the existence of a formal power series solution to a system of polynomial equations can, under suitable conditions, guarantee the existence of a genuine algebraic solution that is arbitrarily close to the formal one. This is the intellectual genesis of the Artin approximation theorem. The argument begins by introducing a class of rings that are intermediate between a local ring and its completion, Henselian rings. A local ring is defined as Henselian if it satisfies the conclusion of Hensel's lemma. A key assertion is that the process of Henselization produces the smallest extension of a local ring in which this powerful lifting property holds. The methodology then shifts to the core approximation problem. Consider a system of polynomial equations f sub 1 through f sub m in variables y sub 1 through y sub n with coefficients in a Henselian local ring A. Suppose one finds solution in the completion of A represented by a vector of formal power series. The central claim, presented here in early forms, is that for any integer c, there exists a true solution in the ring itself whose components agree with the formal power series solution up to the cth power of the maximal ideal. This means the algebraic solution can be made to approximate the formal solution to any desired degree of precision. The proof techniques outlined here are profoundly subtle, involving intricate inductive arguments that carefully construct the algebraic solution step by step, controlling for errors at each stage. In evaluating this section, one is witnessing the birth of a new principle in commutative algebra. The claim fundamentally connects the analytic world of power series with the algebraic world of polynomial rings. It suggests that the completion of a ring, while being a much larger object, still retains essential information about the solvability of equations in the original ring. The reception of these ideas, which were formalized and published in full generality later, confirmed their revolutionary nature within the 1962 notes. This section serves as the ultimate payoff for the entire preceding development, the machinery of localization, dimension theory, and especially completion is all brought to bear on this single, powerful result. It transforms commutative algebra from a descriptive theory of ring structures into a constructive tool for finding solutions. In conclusion, Michael Artin's 1962 commutative rings notes constitute a work of remarkable intellectual synthesis and pedagogical insight. The evaluation of its internal claims, section by section, reveals a meticulously constructed argument that guides the reader from the foundational language of prime spectra to the frontiers of research. The work's power derives from its direct, purposeful, and algebraically concrete approach. The claims regarding the geometric utility of the prime spectrum, the centrality of flatness, the constructive nature of dimension theory, and the simplifying power of completion are all substantiated through clear proofs and a focus on their operational value. The entire intellectual arc of the notes culminates in the groundbreaking approximation principle, a claim that validated the utility of the entire modern framework Artin had so carefully built. The document stands as a testament to a particular style of mathematical exposition, one that embraces abstraction only as a tool for solving concrete problems. It forges a direct and computable path into the heart of modern algebraic geometry, its enduring legacy residing in its coherent demonstration that the deepest concepts are those which provide the most powerful and tangible results.
We really appreciate you tuning into this AI-powered presentation. Our goal is to push the boundaries of AI in content creation, and your input is invaluable. If there's a particular subject you'd like to see us tackle next, or if you have suggestions on how we could fine-tune our AI's creative prompts, please don't hesitate to leave your ideas in the comments section. We're excited to bring you more unique content very soon.